Well, another Monday is here, and I'm not on the road this time like I was last time. I did have to run some errands this morning, so I was running a little bit late. This one here is one of my what do you know tests that I like to do. I used to, whenever a semester started at the college, I used to put these tests out here for my students just to see what they had in their library of knowledge. And it doesn't hurt to go through one of these for just about everybody. Kind of sharpens you up a little bit. I don't know, by the way, if you're any of you guys that are ASE certified are doing the ASE renewal app. And I'm not getting paid anything to say this, but it's pretty cool. I've been going through it on mine, and on October 3rd I'll get my next group of questions, and that will complete all of my 8. I didn't get my ASE certifications all at once. I kind of got them piecemeal but I've been ASE certified now for something like 30 years, and I even got one of those fancy little 25-year toolbox magnets that they sent me back in a few years ago. Anyway, let's get on with our what do you know test, because right now I'm just rambling. Alright, what we're looking at on this question here, an engine has high vacuum and is given additional timing advance up to as much as 50 degrees during what? Now what we're going to do is we're going to go through these questions, and then I'm going to back up, and then we're going to go through and we're going to talk about the answers. So just put the answer down if you've got your paper ready to see what it is that your answer compares to what we're going to say at the end. You can pause the video if you need to go grab you a piece of paper right along now. But let's get on to the next question here. Okay. Dwell is adjustable and can be changed by doing what? Alright. It's question 2A. Decreasing point gap slightly, in other words, pulling the point gap closer together, will do what to the ignition timing? I'll let you think about that one for a minute, or you can pause the video. Slightly after the piston reaches the top of the travel, TDC, the spark plug should fire. Is that true or is that false? Okay. The operation of the ignition coil is based on principles of heated hydrocarbons, magnetic induction, flux capacitance, or spark conduction. This is a DeLorean I actually worked on at the dealership that belonged to the dealer principal. Alright, computerized ignition systems use the centrifugal and vacuum timing advance methods. True or false? Or sometimes. Which one of those 3 answers suits you? Okay. Why are DIS systems, DIS systems, referred to as waste spark system? A, this is the kind of ignition is a waste of time and shouldn't exist. B, this kind of ignition doesn't work well on any vehicle. C, every other spark event happens on an exhaust stroke. Or D, this kind of ignition wasn't used for very long. In a diesel engine, the air-fuel mixture is ignited by A, the exhaust heat, B, compression, C, injector pressure, or D, glow plugs. And then 7A is, why are glow plugs necessary? In a diesel engine with 450 pounds of compression, the air compressed in the combustion of each cylinder approximates what temperature? 600, 1100, 900, or 500? And those are all Fahrenheit readings, by the way. I apologize if you're a Celsius kind of person. Excessive blank is created when fuel is burned without sufficient air to allow complete combustion. Is that CO2, COO2, or NOx? And here's question number 10. What is a closed loop system? You see the answer there. A cooled submerged vacuum tube, a heated hydrocarbon vent, a hose connected to the PCV system, or a system that responds to feedback input. 10A is what closed loop system does just about everybody have in their house or apartment at home. Alright, now let's back up here. Go back to our first question. This one here is something that you might not think about an awful lot, but when you're driving down the highway and you're floating, just holding your speed, 55 miles an hour or whatever, the ignition timing if you look at it on a scan tool or whatever, is going to be up around 50 or 60 degrees. Now, when you're loaded, whenever you go into a heavy load, like going up a hill or whenever you're pulling off real heavy, the timing retards, because if it doesn't retard, it'll ping and labor knock and detonate and all that kind of stuff. Now, I talk a second about detonation. You ever noticed years ago, and here's another little question that's not on the test, what causes a vehicle to diesel when you shut it off? Like if you shut it off and it's sitting there going doom to doom to doom to doom. You know that funny movie called Don't Tell Her It's Me, that had Steve Guttenberg on it from years ago. That girl had this big old Buick. She parked it out in front of this house, and when she switched it off, it kept running like that, blowing black smoke out the back, trying to keep running. She went all the way into a house upstairs, walked around up there, and came back down. When she got back in the car, it was still sitting there doing that. Well, the dieseling is caused on the old carbureted cars if you've got a little bit of an air leak there, because when you switch the vehicle off on one with a carburetor on it, it keeps pulling air in there as long as the engine is something to drive an engine. Well, you'll have carbon on the cylinder heads. If the timing's a little too fast, it'll do that. If it's got an air leak, it'll do that. Well, those little carbon on the cylinder head will have little glowing coals in there. And every time there's some fuel that gets pulled in there by the engine doing its natural breathing, if you've got a carburetor, even though you switched off the ignition system, it's going to keep trying to run. And it may not run, it's not going to run smooth, but I mean, basically it's doing all of this, and eventually it'll do a long snort when it gets through with that stuff. That's not something that anybody with fuel injection has to deal with very often, but one time on a 1991 Explorer, I got that vehicle into my service bay, and they said it would diesel when you shut it off. Now, I'm going to leave this question with you right now, and we'll come back to it at the end. What in the world could make a 91 Explorer with a 4-liter with electronic fuel injection on it diesel when you shut off the key? I experienced this. I only saw it once, but it made all the sense in the world when I went back in there. But I was thinking, this doesn't even make sense. You ever seen one of those things that you say, this doesn't make any sense at all? I don't understand why this is happening. Somebody wake me up. I must be sleeping or something or dreaming. Anyway, on this one here, the correct answer is highway speed light throttle. You're going to have a really high, you're going to have a long time before top dead center. Well, dwell is adjustable and can be changed by doing what to the point gap? Increase, decrease, both, or either. Now, dwell represents the number of degrees of distributor rotation that the points are closed. That's how a dwell meter works. Now, some of you guys that are old enough that you've worked on General Motors' C3 carburetors might remember that you would take a dwell meter and you would connect it to that little green lead on the carburetor, and you would watch for it to bounce around back and forth between 25 and 35 or whatever the number was. I used to do that, and I went to school on those back in '81. But the point is, you can use a dwell meter for other things. I used a dwell meter once on the torque converter clutch wire on an Eagle Summit that was surging, and I figured out after that the torque converter wasn't a straight lockup, even on that '89 Eagle Summit. It basically would have different amounts of lockup from about 10 or 15% all the way up to 100. And I did that by using a dwell meter with a needle. Now, you can't really buy a dwell meter with a needle. Now you can get digital meters sometimes that will read dwell and all that. But dwell is useful for other things besides just setting the dwell on the points. Now, a lot of us would, the gap on the points, you put the little rubbing block on the points on top of one of the little bumps. You'd have the same number of bumps as you had engine cylinders. And you put that thing on there, and it would be about 17 thousandths of an inch or whatever. It's slightly different. And the dwell on a Chevrolet, if I'm not mistaken, was 28 to 32, and on a Ford it was slightly different. It wasn't much different, but it was slightly different. It was like 26 to 30 or something. Somebody else might remember that better than me, because I've slept since then. That was, last time I adjusted a set of points was many long years ago. Um, anyway, decreasing point gap slightly, which means you bring them close together, believe it or not, advances ignition timing a little bit because the points are opening sooner. Because the points open sooner, the timing happens a little quicker. Alright, so that's pretty good little discussion there. Slightly after the piston reaches top dead at the top of its travel, the spark plug should fire. Although some Chevrolet pickup trucks had ignition timing that was supposed to set on 0, you might remember those. You'd see it on the VECI decal. Before top dead center is when it should fire. When you're giving the thing the throttle, and if it's an unloaded situation, you'll see the timing advance. Now, some of the older cars that came, they would, whenever they started using unleaded gas, when catalytic converters came around, General Motors, for some reason or another, was fooling around with their vacuum advance on their on their distributors, and they would hook that vacuum advance up to manifold vacuum. Well, if you know what manifold vacuum does and what the vacuum advance is supposed to do, you would be really confused by that, because whenever you give it the gas, the vacuum drops, their timing would retard. And I think they were doing that to keep it from pinging. They also lowered the compression a little bit on those. You might have noticed the pistons were dished on the ones that were, they would be flat on the ones that were made for leaded gas back in those days. And when they first started using unleaded gas, they lowered the compression a little bit by dishing out the pistons and all that. But because of the fact that the gas will only burn so fast, whenever that spark lights off, the faster the engine's running in an unloaded situation, the sooner the spark has to happen. Now, what I would do is I would find me a ported vacuum outlet on the carburetor. You could piddle around. There were several little ports on the carburetor. Ported vacuum is the one that's only got vacuum when you're applying the throttle. And I would repipe the rubber hoses going over there so that whenever you would give it the gas, that ported vacuum would go to the vacuum advance. And you go from a car that had a little dab of a stumble when you took off to one that would burn rubber. It was a huge difference when you used ported vacuum to go to the vacuum advance. Now, some of the Ford distributors had adjustable vacuum advances on them where you'd stick an Allen wrench right in through the hole where the vacuum hose plugged in, and you could adjust that vacuum advance to how much vacuum advance you wanted it to have. And so, and then, you had, of course, the centrifugal vacuum advance in there too, which would, the faster it spun, the more it would sling the flyweights out and it would advance it too. And what General Motors, on some of them, the vacuum advance will pull the breaker plate around to change the time when the point's open. But on the GM ones, it would basically sling those flyweights out and it would move the center, the reluctor, for that. I don't know if you ever noticed that or not. Anyway, that one right there is not supposed to have an after top dead center. If you got one having an after top dead center, it will make it run hot and it will make it have horrible power. Terrible gas mileage, or just all kind of issues like that. The operation of the ignition coil is based on the principles of magnetic induction. Obviously, it's not flux capacitance. Everybody knows about that. Spark conduction, blah, it's just a bad thing. And heated hydrocarbons. That was kind of funny when I was first teaching. I would put something about a heated hydrocarbon vent on some of the tests, and some of the students would get really confused by that. And they would choose that answer because they weren't sure what that meant. Computerized ignition system uses centrifugal and vacuum timing advance methods. True or false? That's largely false. One of the things that you have to use for a caveat on that was some of the earlier ones would do a mixture of them. As a matter of fact, even some of the, I always thought it was kind of interesting, some of the Asian vehicles have had a tendency to use points in the distributor, even though they had an igniter and the ignition was electronic, and the points were only used for a trigger. They didn't actually carry the power that was going to the coil. There were points in there to confuse you if you didn't know what you were looking at. And so it was a sort of a mix of the old and the new on that. Believe it or not, and I haven't ever done this, but I know you could probably do it, the old Chrysler electronic ignition that came out in 1972, you had your pickup coil wires going over there to your distributor, and then you had one going to the coil, and you had power and ground going to the module. So you could take that, if I was testing a module on one of those old vehicles, I could unplug the pickup coil, and I could short those two wires together, and the spark would go pop, 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 pop. All right, so I was thinking, if somebody wanted to be a real character, they could take the electronic ignition distributor out of there, and they could drop a regular distributor in there with points in it, and they could wire those points up if they did it right, so that all it was doing was putting the points together every time the bump came around, and you could probably run that Chrysler with using the points for a trigger in the electronic ignition module to actually trigger, fire the coil. And so that one there is mostly false, but be careful about that, because some of the really early ones, they hung on to some of this old technology and mixed it with their new technology. That's the only reason I was going there. Why are disk systems referred to waste spark systems? Well, every other spark event happens on an exhaust stroke. The first time I ever saw first vehicles I know of that had this on there that were widely produced were the Buicks in 1985, I think, had this ignition system on them. That was about the same time, if I remember right, that they came out with mass airflow. Of course, in those early days, it was a disaster. But they used distributorless ignition. My '06 Explorer has got distributorless ignition on it, so it's been used for a long time. It works really well as long as you've got good components. Some of those smaller distributorless ignition coil packs on some of the Fords had a tendency, one of the towers would go dark because it would be internally shorted. They used to teach, whenever this first came out, that because it was firing in a loop, like you see right here on the screen behind me, they claimed that if you unplugged one of these, that the other one wouldn't fire, but that's not so. That spark is going to find somewhere to go, and the only one that didn't fire would be the one you unplugged. Now, occasionally, you'd see the coil, like I say, be shorted on the inside, and you'd find out you had a dark tower. That happens sometimes, too. But every time they changed up the ignition system, the voltage went up. When you were popping the coil with points, you might have 40, 50,000 volts tops. Whenever you went to the E-core ignition in General Motors' high-energy ignition, it was going up to like 85 or 90,000 volts. Whenever you went to this kind of ignition, it wound up being 110,000 volts or something like that. So they keep going up, and that's really, if you want to not have the spark run through your body, you can put on one of these wrist straps like computer mechanics use whenever they don't want to use static, they don't want to damage a component. And if you hook your strap around your wrist, and you can build you one and have you a piece of hook it to a ground over there. If it does jump and hit your hand, it'll go through that ground instead of running through your body and stopping your heart. It won't stop your heart every time, but it's a bad bet to have that high voltage go shooting through your body, like if you're leaning on something and and it pops all the way through you and all that. And everybody that has been around all that long knows that you take a capacitor, the points, the condenser out of a distributor, you can lay it on the engine block, let the spark jump to that little terminal on the end of the wire that comes out the end of that thing, and it stores all that voltage in there. If it's a really good one, it'll store that voltage for a long time. And what people used to do was they would have this little thing, they would pop a spark to it and store all that voltage in there, and then they would lay it down somewhere, and then some yo-yo would come by and pick it up and touch it and knock the fire out of him. Beware of anybody who throws you one of those. If somebody says, "Hey, here, catch this," and they throw one of those little condensers, looks like a little firecracker with a steel housing and a wire for a fuse, the little terminal. It is pretty much like a firecracker, because if they throw it and it's charged up and you catch it, you're going to hear a loud pop and it's going to knock the tar out of you. But anyway, in a diesel engine, the air-fuel mixture is ignited by compression. Now, the problem with that is, whenever the engine is cold, the compression heat is being absorbed. So, heat is what actually moves. You can generate heat by squeezing the air, right? Okay, so if you squeeze the air and the metal, the head, the piston, the cylinder walls, if those are all cold, then you're going to absorb all of the heat you're creating by compressing the air into those metal surfaces. And That's one of the reasons the glow plugs are necessary. Some people that don't understand diesels have the idea that the glow plug replaces the spark plug on a diesel. And glow plugs, the newest model diesels will have glow plugs that, they'll have a glow plug controller that will keep track of all the glow plugs. One of my students had a job that she took in on the side where she worked on a Dodge Cummins diesel, and the remote start wouldn't work. And so she was a pretty smart girl. She'd been in the Marine Corps and stuff like that, and she worked on Humvees and all. But I had taught her over there to think critically. And we hadn't worked on any Cummins over, but she just got to reasoning this out. And so she got her scan tool right there in her yard, and she plugged it in, and she found out that 3 of the glow plugs were burned out. And so she went ahead and put an entire set of glow plugs in that thing, and then she cleared the code. And she said after that the remote start would work. Well, see, with those codes stored, that controller, and I don't know what year model this Dodge was, but anyway, she said that with the codes stored, as long as those codes were stored and those glow plugs were bad, the remote start wouldn't work because it didn't trust itself to start without running the battery down or burning the starter up or something. And so it has to feel like there's a full, good full set of glow plugs in there. So she just replaced the glow plugs, cleared the codes, and the vehicle was fixed. She felt like a hero. All right, in a diesel engine with 450 pounds of compression, the air compressed in the combustion of each cylinder approximates 900 degrees because you get about 2 degrees Fahrenheit per pound of compression. And most of the time the compression ratio is going to be from 16 to 20 to 1 on most of your diesel engines as far as just the straight compression ratio. The numbers are going to be, the volumetric efficiency numbers are different, and the compression may be different if you've got a turbo on there, because the turbo shoves the air in there instead of letting the naturally aspirated, the pistons draw it in and all that. But turbocharging increases the volumetric efficiency of engine to above 100%. Because it's kind of interesting. I don't know how well this works, but some of these people will buy these neat little kits where they'll put a squirrel cage blower blowing into their intake, which is kind of funny. I don't know how much positive pressure that creates in the intake. It seems like it would have to help a little bit, but I don't know how much. Anyway, excessive blank is created when fuel is burned without sufficient air to allow complete combustion. This right here is the answer to that. CO, because if you don't have enough oxygen, if you've got more fuel than air and you do have combustion, but it's not complete combustion, every carbon molecule wants to get married to 2 oxygen molecules and make CO2. That's your cleanest burn. Okay, so if you've got a rich mixture, you're going to have CO, because only 1 oxygen molecule will be with each carbon molecule. That's a rich mixture, and that's not too hard to figure out. NOx is created when the air in the combustion chamber goes over 2,500 degrees during combustion. Now what we do to take care of that is we recirculate exhaust gas. That's inert gas that goes in there and it causes the cylinder not to burn as hot. And so if it doesn't go above 2,500, you don't get as much NOx. Remember I was talking last time about on your Ford Contour, when they first started putting variable cam timing on those, they were closing the exhaust valves early to trap some of the exhaust gas in there for the same reason. And then, of course, O2 is obviously not the answer to that. But you can have a really dirty air filter. One time this buddy of mine was working on a Mustang that come in, and that thing wouldn't start for love or money. It wasn't that old either. It was nearly a new Mustang, and it was under warranty. And he worked on that train to finally figure out when to start. When he finally found the problem was when he finally decided to open the air cleaner housing. Now this car was clean, don't get me wrong. It was the car was clean, the engine was clean, everything was clean, but it was a no start. The air filter element was nothing but a solid blob of mud. And apparently this guy had gone through some deep water or some mud or something on that Mustang, and it completely clogged the air filter. And he had apparently didn't want his folks to, or actually just might have bothered him because it was muddy and all. He washed it all off really, really good somehow. I guess he towed it somewhere. But when it came in, it was deceptive because it was absolutely perfect as far as the rest of the car looked, but that air filter weighed 10 pounds. It had so much mud in it, that beat all I ever seen. He felt dumb because he didn't check the air filter to begin with. Sometimes when I was planting bugs on vehicles that I was trying to get students to work with, I would take a little bit of tape and put it over the part of the screen right in front of the air, or sometimes I'd actually cover up the little hole going to the mass airflow, and that would give them all kinds of problems. Or you could stuff a shop rag in there, and it would, you want something that's not going to hurt the vehicle, but will cause them to have to go look at the air filter and look up in there. And sometimes spiders build nests and stuff up in the, or mosquitoes will get stuck to the hot wire on your mass airflow sensor, and that causes all kind of grief and everything. Closed loop system is what we most think of most often with a closed loop system is our oxygen sensor reporting back to the engine controller how the mix is looking, so the engine controller can work with fuel trims. That is the most common closed loop system that we are always thinking about. But there are other closed loop systems, and the fact that you've got your EGR is typically a closed loop system if it's still on there. It wants to know how much EGR is flowing and how to adjust it. There's several closed loop systems on vehicles nowadays. Your house has got a closed loop system in the thermostat. The thermostat's measuring the temperature, and it has control over whether the AC comes on or not. So that's a loop. Now think about this. Unless you've got a satellite, one of those watches that talks to the like the sky clocks that actually talk to the thing up in Colorado or whatever, your watch doesn't know if it's right or wrong unless it's one of those, right? Or unless it's maybe connected to your phone. But this wristwatch right here is about a $20 wristwatch. It doesn't know if it's right or wrong. That is an open loop system. It's a fairly complex piece of machinery, but it's not a closed loop system because it can be wrong and not know it. The closed loop system is always going to have feedback, and it's going to have the ability to make changes based on the feedback. Now, whenever you're deep into the throttle, your oxygen sensor is typically ignored on the systems I'm familiar with. Whenever the engine is cold, probably for about a minute now, it used to be longer, but whenever the oxygen sensor is not being paid attention to, that's open loop. If you've wide open throttle is an open loop mode, cold engine's an open loop mode. There's some other open loop modes where it's not paying attention to the oxygen sensor if it can't trust it, if it knows it can't trust it. But once again, if it can't trust that front one, it may start ignoring that one and use the one behind the catalytic converter. So be aware of that too. There's a principle of that called total fuel trim that you may have seen. CarQuest Technical Institute puts out a really good course on that. So, and if you happen to see one of those, they'll talk to you about that oxygen sensor behind the catalytic converter making a difference. Well, this has been a lot of fun. I hope you got something out of it. I really enjoy talking about this stuff with people that will listen. I could talk about this with my wife, but she gets bored with it really quick. But anyway, you guys have a good week, and I've already got something prepared for you next week, and I'll be looking forward to seeing you then. Y'all have a good time. And if you're working on cars for a living, make yourself and your boss man some money. If you own a shop, make yourself some money, and do a good job. Be honest with your customers and make sure that they get your day's work for your day's pay. Most customers don't mind paying the bill if the vehicle's fixed when it leaves. Everybody knows that. Anyway, talk to you guys later. See you next time.